it's 4.5. And what is the distance from the midpoint to each of the endpoints? Everybody good with that? That would be 2.5. Okay, so write an absolute inequality that represents the points on the graph. What does it say? Okay, on the graph. Anybody? So we know that it's going to go. What will our symbol be? It's a closed circle, so it is going to be
Greater than or equal to?
okay. So anybody have an idea what that would be, Cassie?
For CF28.
Yes.
So I said, the absolute value of x minus 4.5
X minus 4.5.
is less than or equal to 2.5. How? Because the middle of the segment, like, is 4.5. So anything subtract that is going to give you the difference between the middle and one of the ends, and it has to be equal to or less than 2.5 apart.
Good. Very nice. Okay. Does everybody understand that? You know that that's the midpoint. I don't get it. Okay. This is the midpoint of the segment. And you know that from here, this is kind of like the electric cord. How far can I get from there? I can go 2.5 feet this direction, or I can go 2.5 feet the other direction from the midpoint. And can it exceed that quantity? No. Okay, so that's why I know that some number that would be minus that. So if I solve this, I have x minus 4.5 is going to be less than or equal to 2.5, or x minus 4.5 is going to be greater than or equal to a negative 2.5. So I add, and x is going to be less than or equal to, 7? Or, and what do I have here? 0, 2. So x is going to be less than that. So when I plug that in there, can my values exceed the greater than or equal to 2 or less than or equal to 7? Does that make sense in terms of our range? Okay, does that make sense to everybody? Okay. All right. I came across a couple of problems. Does anybody else have any questions on their homework? Kristen? 26. Okay. Number 26. Anybody want to explain how what do you need to do here? What? Somebody said it over here? Simplify. What are you going to simplify?
You gotta solve for what's inside the parentheses.
Yeah, I'm going to try to simplify what's in the absolute value box, if you will. So I have x minus 2x minus 6, and then I'm just going to simplify that. Yeah. Right? Distributed property?
Oh.
Okay.
Correct.
All right, and then solve it from there. Anybody have any, does that answer your question? Stephen, sorry.
My question was on 36. I know that they're not the same, but I didn't know how to explain that, because one is outside the absolute value, one is inside the absolute value. How do you explain that it's different? Would you solve it and say the answers are different? Or?
Okay, hold on a second. Can you give me an example? So
By
here
solving
we
it?
have, let's see.
Because for one of them, you could add it to a negative number. For one of them, you have to add it to a positive number.
Okay, so would they equal each other?
No.
No, I mean, you could just say that if you added anything to either one, your result wouldn't be the same.
Okay.
So for instance, if you added 0 to, and what was the other one?
It was 2x.
So if this is 3, let me see, is that the same? two x, if x is 0, was that the problem, sorry? Oh, it would
Oh, it
be,
is the same.
yeah, it would
Oh,
be,
it's
but
the
is, wasn't that the problem?
No, it's not the same, is it? I saw the thing.
Plus, and this one. Are these gonna be the same problem when you solve for them? No, because if this one was, sorry, these are the two different problems. If I have two x plus 3 is greater than 6, or 2x plus 3 is going to be less than a negative 6, this one is, I'm gonna get my absolute value by itself. Are they the same problems? No. So they end up not being the same problem.
You just minus 3 from the
Yeah, what do you?
Is my absolute value isolated in this problem? Once my absolute value problem is isolated, then I can go about rewriting it. But in this case, my absolute value wasn't isolated. I got rid of the 3, and now I could say, and then solve it. Are they the same problems at this point?
No.
No, they're two different problems. All right? Okay. I have two problems I'd like you to do. And this goes back to the traps that we talked about last week. And we had some unfinished business, and I wanted to take care of that before we move on. So I'd like you to solve this problem. Can you see that? Is there too much of a glare? Can you see that?
Read it on the same paper.
Yeah, just, I just wanna make sure that just because it has a negative in front of the absolute value, that we aren't making a blanket statement.
What do you want us to do, solve?
Solve for this problem. You solve it? Could you graph it? You solve and graph it? Okay, Laura, did you get that? You done?
You divide
I
by
didn't mean to
4.
put you on the spot. Are you done?
Divide by
Okay.
negative.
How do I get, is my absolute value by itself?
No.
Can't you just add along?
What, it doesn't just say -4 times whatever's in the absolute value box?
Uh-huh.
What do I need to do?
Divide by negative 4.
Do I need to get rid of it? Am I gonna divide by 4? Yes?
Yeah, negative.
Okay, and then what do I have?
7
Do I have 7/4 is greater than the value of x?
Yes.
Yes? Okay, so it's going to be, what will my values be? If I gave you, it's Monday afternoon, you guys are asleep. If I said to you, give me the values, how would you graph that?
Everything less than
What? Wouldn't
You
it
just
be?
put the 3 in
You put it open.
Stephen?
Wouldn't it just be,
Less than,
it's less than 3.
or -3, right? I mean, wouldn't I solve this problem twice?
Yes.
Okay, well, aren't we here right now in this particular problem? Aren't we solving this twice? We had a fraction in there. You guys, are you with me?
Yes.
Okay, so if I graph this, would it be that x is going to be greater than, the value is greater than a negative 7/4 or less than a 7/4?
Yes.
Am I solving the problem twice?
Mhm.
Okay. It's open, and I have all the values that are inside that range. Okay, is that different than the problem that we did on Friday?
I don't remember.
Okay, did you have a piece of paper that you wrote the traps?
Yeah.
Okay.
What is the trap?
Do you remember this problem? We had quite a bit of conversation about, this problem. Do you remember that? Okay, so, and we made a statement, we had a little bit of conversation about it, and we didn't, I wanted to get through, but I wanted to come back to this, and we said, didn't it make sense that in just looking at this, that our solution was going to be all the real numbers? Okay, do you remember? Why was the solution all the real numbers here? Yeah, because whenever I multiply, whatever is coming in here, in this particular problem, was going to be, they would be less than 9. But in the problem that I just gave you to do, we're saying that this quantity is actually going to be less than that, and we were able to solve it. So you need to look at the problem and you need to check your work and then put something in there. And so when I solved this problem, I thought about it and I thought, can I check my work here? And that's what I'm saying is check your work. So we're saying that x has to be less than 7/4. And I thought, all right, well, what about 6/4? 6/4 is less than 7/4. And when I multiplied it, is this a true statement? Okay, it is a true statement. So there's a limit here. Had I gone to 8/4, so instead of using that, if I made this 8/4, and these canceled out, I would have negative 7 is, this would be what, a negative 8? Is that a true statement? No, it's not. So you really need to be careful when you end up with these negative in front of the absolute values. It's not always just all the real numbers. And that's, I just wanted to make sure that we were clear on that. Okay, so let's try another problem that's similar to that. And tell me how you would solve this problem. And here's the thing.